Hi, good afternoon. Today we are going to talk about how to make an active plotter of zero of a quadratic function. So the first step is to write your function in order to have here the graphic. The function we will use here is the function of x that is equal to ax to the cubic plus ax squared plus bx squared, sorry, plus cx plus d. These are our sliders that will help us to manage here our graphic. So let's click here in create. Let's close the. So this is our function in the graphic. So with these sliders, you will modify it in order to have it as you wish. So in this case, we will modify it. Okay, the range also it's from -5 to 5, so it's not such a big rate, so we can manage the graphic better. So let's manage like here. Let's put it more like here. Okay, so now we have our graphic. The next step is to mark a point in the line of the function. So we go here, point, and it can be in any point of the function you want. Let's do it here. Now you have marked this point. You have to add a tangent line that will help us to find the slope. So you give click in this and you give click here in this point and in another point of the function, maybe here. And this is our tangent line. So if you notice, you can move it and this will move according to the graphic. So you have to notice that because this will help us to find the slope of any point in the graphic. So to find the slope, now we give click in in this bottom, and we give click here in the point of the tangent line and the graphic. And notice that if you move, wait, if you move your point, the slope will be the slope is changing. In any point you put the slope, it will change, like here, here, and now. Notice that here it's a positive slope, and here it starts to be a negative slope. Okay, so let's put it again so you can see it. Here it's negative, the slope, and here the slope is positive. But when it starts reaching here, it becomes negative again. And then when it starts getting here, it gets negative again. This part is the one of the positive slope. So now that we have our slope, we can look for our maximum point. The maximum point is a value in a function that at a certain point it's the greater value in all your function or in all your graphic. For example, here, let's do it zoom so you can see it. If we move this point here, the slope is 0. This means that we reach to our maximum point in this graphic. Why? Because you have your values here and they are increasing until they get here. Here, when the slope is 0 and when you can see the tangent line, it's like this, means that from this point in your graphic, the next values will start decreasing. So that's why the slope start getting negative, because they start decreasing. Here, it's your maximum point. Now, you can also look for your minimum point. The minimum point is a specific point which is the smallest value in the function. It's the contrary to the maximum point. So if you move your slope here, also when it gets to 0, means that you get your minimum value, your minimum point. Why? Because these values start decreasing until they get here. This is your smallest value because now every single number after this will start increasing. So this is the smallest number you can get in this graphic, because as you can see, here's the slope starts decreasing, but here the slope is 0. And also there is a point in the graphic called the critical point. The critical point is a particular point of the derivative in which the function is 0. What means this? For example, here the critical point will be like from here, approximately. And what do this means? Well, you have your graphic. Let's do it. Here you have your graphic and you have these two curves. So here, this curve is your convex curve. This means that this curve lies completely on one side of the tangent line, and this is your convex curve. Now, if you move here, this is your concave curve. So your critical point will be the one here, where your point is 0, and this means that the convex curve ends and the concave curve starts, or the concave curve starts and the convex curve starts. Like this is the point where the function will be in 0 and will show you that this concave curve starts like from here to here and the convex curve starts from here to here. And well, this tangent line is the straight line that touches by little the curve of the function that in this case is this function. And well, we hope you like it and you learn a lot. We'll see you in the next video. Bye.